Okay. All right. So what we're going to do in chapter 12 is we are going to brush up just a little bit on statistics. And so we're going to start in section 1. We're going to talk about what's called sampling techniques. But before we get to that, and I can tell you what a sample is and the techniques for taking a sample, I'm going to tell you what statistics is. So first thing is statistics. And there will be a couple of multiple choice vocabulary questions on this next test. Nothing fill in the blank. I try to make them as obvious as I can, but there's a bunch of different terms. So statistics is the science of gathering, analyzing, and making inferences from numerical information that you obtain in an experiment. And so each of these different things can be a different area of statistics. Some people specialize in the trying to gather data in a way that the data will be meaningful, because you definitely don't want to insert any sort of biases into the data when you gather it. Analyzing it, that's where you get a little more mathematical, and being able to, and we'll talk again briefly about some of the tools to analyze data. Making inferences, that's not where we're going to go in this class. That would be more of a statistics class, like what predictions can you make, what certainty can you have when you make those predictions. That's a super interesting aspect of statistics. So, and again, statistics deals with numeric information. So this numerical information is called data. So when you see that word bantered about in statistics, that is referring to the numbers that have been gathered for whatever it is that you're studying. And so there's two big areas of statistics that you'll see. Like some of you, if you're going to go be a teacher, I don't know what your life goals are, but anybody's going to go be a teacher, you'll take a statistics class for teachers about making good tests and being able to infer if it was a test that actually measured what you wanted to. So that's just one area you'll take some statistics. So what's called descriptive statistics. Descriptive statistics is concerned more with collecting and organizing and analyzing the data. So how do we get it? How do we display it? Like what does a good statistical graph look like? That's going to convey what you're trying to convey. And then analyzing it, again, like what's the center? How spread out is the data? What are groupings? Are there any patterns that you can see? All of that is concerned with descriptive statistics. And then there's something called inferential statistics. And inferential statistics is concerned with making generalizations and predictions from the data that has been collected. And again, the data has to be good, the analysis has to be good in order to make good predictions. Also, the assumptions that you make have to be good. Okay, so all elements of something you're studying is called the population. Now, populations can be big, populations can be small. If I was studying the grade point averages of Polk State students, then the Polk State students would be the population. Okay, if I was studying the grade point averages of all college and university students in the United States, that's a different population. Okay, so populations are declared, and then depending on the size of the population, you're probably gonna study a subset of the population, and a subset is called a sample. So you see this like when a company's testing a new drug, they can't test it on everybody. So what they do is they grab a sample of the population of people that are potentially going to take it. So again, that's why your sampling techniques have to be good. So there's different, again, we're just doing real basics here. So there's more things to statistics than what we're talking about, but I'm giving you kind of the basics here. So the different kind of samples that you can take, the first type is called a random sample. What a random sample is it's a sample that, I'll write this down, but it's a sample in which each item is selected with an equal chance of being picked. Okay, so each item in the sample, or excuse me, each item in the population has an equal chance of being picked. So I'm going to write that down. each item in the population has an equal chance of being selected. Now that's harder than it seems to be able to do. You've got to design something well and make sure that you're not overlooking anything to be able to design something that's going to be a random sample. But it's random sampling is one of the most common types of sampling techniques. The next type of sampling technique is called a systematic sample. And the way you do a systematic sample is you select a starting point, and then you select every nth item, n being a number. So you'd select every 10th or 50th or whatever item. So you select the starting point. And then you select every nth item. I mean, kind of the classic visual of this is if you were like on a bottling line, you know, you're watching all the bottles that have been filled up go by, but you want to make sure that the machine's filling them up appropriately. What you might do is you might take like every 100th bottle off the line and make sure and test that and make sure that's going on. So you do something, but you do it the same, being systematic. That's the important thing to the systematic sample. That way you are not giving anything more likely chance to be selected than something else. The next two kind of seem similar, but there's one big difference between them that I'll try to point out and make known to you. The next one's called a cluster sample. And some books call this an area sample. And there's kind of the key word to this. So when you're writing down the word area sample, underline the word area. What you do in a cluster sample is this: you divide your population into some sort of geographic section. Okay, so whether you have a map or whatever, so you divide your population into geographic sections. Then you take a number of those sections at random. And then you choose all the elements in those randomly selected sections. One of the examples that I think is in your homework or is on the sheet that we're going to do or something has to deal with like school districts. Okay, and you want to kind of get like a teacher survey from school districts. So, you know, you've got your schools, everything's divided up, students go to a particular school. And so then you randomly pick some of the schools and then you survey all the teachers in those schools. That would be an example of a cluster sample because you've chosen where you're going to sample based on geography, based on the area distribution. Another place that this was used in the past is to kind of get the picture of what populations of animals look like. You take a overhead picture of a certain area, and then you divide that up into blocks. Then you'd pick some of the blocks and you'd count all the animals in the blocks. And that would give you an idea of the disbursement of the population, again, based on area. Now, that looks similar to this next one, which is called a stratified sample. Now, stratified sample, the difference is you're going to take the population and you're going to divide it up based on some characteristic. Okay, so you're going to divide the population up. So it depends on what you're studying, would be the basis of what the characteristic is. Anytime you fill out a survey, you're kind of entering into a stratified sample, because then when you enter a survey, one of the first things they ask you is what age range are you in, what gender you are, what your financial status is. Those are strata. Okay, those are different ways to divide up a group of people so that you can study based on different characteristics. And they can give you different insights, like does something have a trend based on gender, based on age, based on economic status, or something like that. So the different characteristics, and there's lots of them, anything could be a strata, but kind of the popular ones that you see a lot are age, or race, or national origin, or income. And then I'm running out of room, but I think you kind of get the point. Any way to divide people up into similarities so that you can study and see if, statistically, does that similarity make any difference to whatever it is that we're studying? So you first divide the population up by some characteristic, then take a random sample of each strata. So if you were studying something and you divided up your population by age, 20 and under, 21 to 30, whatever your strata would be, then you would go in and you would take a random sample from each and every one of the different categories of ages that you had in order to get a sample. This last one, probably you would know this from the word. This last one's an example of a bad sampling technique. Okay, a convenience sample. And in a convenience sample, you just use data that's easily available. Okay. I mean, so for instance, if I was studying Polk State students for something, let's just say grade point average, well, you all here are convenient. And so I could take your data, but that's not necessarily a good sample, because are you representative of the whole population of Polk State? Right? You're morning students. You tend to be younger, so I'm skewing and putting in some maybe unintentional bias into my data because I'm doing something that is convenient. So so when you're looking around, some types of convenience samples, probably the most popular is what's called a self-selected survey. What a self-selected survey is it's a survey that you choose whether you're going to participate or not. So like you get off the phone and you've been on the phone with a company and you're getting some service maybe on your computer or something, and then they email you a survey and you decide whether or not you're going to do it. It's not mandatory or anything like that. That's a self-selected survey. And the problem is people that in a self-selected survey, basically people that are really motivated are the ones that are going to answer the questions. Or if you say, oh, answer this survey, you get a $10 gift card. That introduces bias into your data, because now you're getting people like me who are cheap and will do just about anything for a free gift card, right? So that becomes a problem. Another big one is when you take a survey and you get what's called leading questions. And what a leading question is, in case you're not familiar with the term, a leading question is one that is kind of guiding you to the conclusion the questioner wants you to have. Okay, so you see these all the time, both pro and con. So a lot of times I read a lot of stuff about in the climate change and all that's going on with that, but everybody has an agenda, and when you read the surveys, a lot of them have very leading questions, so if it's somebody who is very into climate change and the world's going to end, then they're asking questions of something like, how long do you think the human race has to survive? Something leading question. And then if the other end of the spectrum, people who don't think climate's changing at all, similarly, you can ask leading questions one way or the other. So none of this is exclusive to any sort of point of view. People use statistics badly all over the place. Another type of bad thing is to use a small sample size. If you do take a full statistics class, one of the things that you will talk about is what makes a sample size appropriate to have any sort of conclusions that are relevant. If you have a sample size that's too small, then you're introducing an unintended source of error. One other thing that I have is, and there's lots of other bad things you can do in a convenience sample, but you can ask vague, or you can use vague or ambiguous words. So when you see words that there are multiple meanings of, or maybe you don't know the definition of, a lot of people don't want to admit that they don't know things, and so they just answer the question anyway. So for instance, one of the biggest ones, and we'll talk about this next week, is the word average. The word average is a general statement, but we associate it with something specific. So in our mind, we're thinking one thing is the average, and the questioner thinks another thing, or can use a different average, because the average actually refers, and we'll learn this next week, the word average actually refers to 4 or 5 different types of measurements you can take, and so you can manipulate your results like that. Or if you say the word like best, okay, any sort of value word, that makes your data suspect. Whenever I teach a statistics class, and this is not a statistics class, we're just doing a quick overview, but one of the things that I like to hit on most is this idea that correlation is not equal to causation. And what that means is, if you, through your data, you see 2 things are related, that doesn't necessarily mean one thing caused the other. Okay, there could be other factors, and there likely are other factors that you have to investigate. This is probably one of the most dramatic things in any of the media that you read, that as soon as a relationship is found, immediately people are trying to make value judgments that one thing is causing another. Just be really careful, and that's the value in taking a statistics class, is you being able to discern or to determine, is one thing leading to the other, or are these related by some third thing that we have don't have any data about. All right, flipping the page. So now that I've given you all those things and bored you half to death, sorry about that. We're just going to do a few examples. So you might want to flip back and forth between the pages. So now we're just going to go in example 1. I'm going to do the first couple with you and then give you a minute. We're just going to try to determine, this is a way for us to kind of learn those definitions, which one of the sampling techniques is being referred to here. So for instance, example 1, the A problem says every 20th soup can coming off an assembly line is checked for defects. Which one of the sampling techniques does that look like? Yeah, systematic. Systematic, remember, you start at a random spot and then you pick every nth item. And so the key here is every 20th soup can. That's what tells you right away that this is systematic. I'm going to do one more, and then I'm going to have you do the other 3. I'll give you a minute or 2. So a $50 gift certificate is given away at the annual bankers convention. Tickets are placed in a bin, and the tickets are mixed, and the winner is drawn by a blindfolded person. Which one would you think that is? Yeah, random. Okay, all the tickets are together. Everybody's got an equal chance, supposedly, of being picked. So that would be a random sample. That's great. So I'm going to give you like a minute and a half. Look at the next 3. You don't have to do example 2. I'll give you separate time for that, and determine which of the sampling techniques are the C, D, and E problem. All right, so the next one says, children in a large city are classified based on neighborhood school they attend. A random sample of 5 schools is selected. All the children from each school are included in the sample. Which one is that? I'm sorry? Why'd you say cluster? You're 100% right. Okay, so one of the clues is, yeah, it includes all the children from the schools that are selected, so that's cluster. And then the first clue is that it's based on the neighborhood, so it's geography. Okay, so it's based on area, and then I'm going to underline the thing that you said, all the children. That is another good clue that is a cluster sample, because that's the only one of the sampling techniques that includes that word right there. Great job. The D problem says the first 50 people entering the zoo are asked if they support, that should be the word an increase in taxes to support zoo expansion. What kind of sample is that? Yeah, convenience. And you can notice the skewing of the data. You're at the zoo asking about increasing taxes to support the zoo. Well, of course, you're going to be more likely to get people who support the zoo when you're standing at the front of the gates of the zoo. So that's what would be poor about that. Lastly, the E problem says all registered vehicles in the state of California are classified by type, whether it's a subcompact, compact, etc. A random sample of vehicles from each category is selected. That one is a, yep, stratified. In that case, the strata was type of vehicle that is being driven. Great job. Excellent. Any questions? Okay, you do the same thing for example 2. Okay, so give you a minute or two to go through the same sort of deal. All right, so here we go. A, the bingo balls are in a bin and they're shaken, then one is selected from the bin. That's an example of what do you think? Yep, sure, random. Everything has an equal chance of being selected. Beautiful. A state is divided into counties. A random sample of 12 counties is selected. And then I repeated that statement for some reason. So a random sample of 12 counties is selected. And then I should have said, and then data from each of the 12 counties is grabbed. What is that one going to be? Cluster. So I obviously need to retype that example. That was poor typing by the Perkster right there. Okay, C, every 10th Samsung television coming off an assembly line is checked for quality. Yep. Viewers on Netflix are classified according to age, and a random sample of viewers from each age group is selected. Yep, perfect. And then last but not least, a student government at a college is electing a president. The first 25 people leaving the library are asked whom they will vote for. Yep, exactly. Great job. All right. So far, so good. We doing all right on these different terms that we've got going on here? All right. So the next kind of thing is just taking a look at, again, just giving you some basic knowledge of some things. Maybe it's helpful, maybe it's not. Another misuse of statistics, or a way that statistics is displayed poorly, is through bad graphs. So looking at these two graphs, don't worry about what's wrong with one of them. What's the difference in impression in these two graphs right here? Yeah, this one looks like it's changing a lot, right? What is the problem? Can anyone notice what the problem with the graph is that looks like it's changing a lot? Yeah, so right here, this is the problem. There is a problem with the scale. The scale has been adjusted. And so you guys, though, you did very well in identifying the reason why that's done. It gives you, because remember, graphs, what's the purpose of a graph? A graph gives you a visual. We're visual people. Our brains take in pictures and automatically draw conclusions right from them. So one of the easiest ways to lead people to a conclusion you want is to change the picture and make it look different. So in this one, you can see the scale's been adjusted. This happens all the time. In fact, if you do read stuff about climate change, one of the biggest things that gets done in climate change arguments is very bad graphs. It doesn't just have to be on the y-axis, it can be on the x-axis. So if you just scope in on a particular range of years, that kind of leads to the conclusion that you want, whether it's for or against. Again, this is not about taking a side. You can lead people to the wrong conclusion, or a disinformed conclusion by changing the scale. So be really careful. Like whenever you see a graph online, your first thought should be, what is the motivation behind the people who made this graph, and what is the scale right? Am I seeing a full spread of years? If you're talking about climate, am I seeing the full scale on the y-axis so that I can see, is this really as dramatic as I'm being led to believe? The next one, same sort of thing, but just a different graph. This time we have bar graphs instead of a line graph. But again, you know what the error is, but again, what's the perception that you are led to that's the difference between those two graphs? Yeah, the scale. Like, look at this one. How do you think, if you just looked at this, you didn't look at the scale, what is your brain saying is the difference from 2018 to 2019? How many times bigger does 2019 look? Yeah, like 5 or 6 times bigger. Right? Because whoever made that graph just zoomed in on the top of it. But when you have the proper scale, there is a difference, but is it as significant as the first graph leads you to believe? No, not at all. I mean, I guess depending on the situation. But again, you can see how the visual, if you don't look at the scale, if you're not analyzing what's being done statistically, you can get worked up one way or the other about those things. Bar graphs, one of the things we'll learn when we come back next time is when we do a bar graph, the area of the bars has to be proportional to what's being talked about. So like this one, we can see that we can put this 2018 box, I'm approximating, like 5 times. So this is 5 times the area of that. So your brain says, oh, that's 5 times bigger. So that in bar graphs, your areas have to be proportional. They have to be accurate. And so this one, that's why this is the better graph over here, because the areas are representative of what's going on. Same sort of thing with this one right here. What somebody did here in an effort to notice, just because the numbers are simple, I got this example out of the book, although I used to have an example from online, but got eaten up in my book. NASA put it out, of all people. This says things have doubled, right? It goes from $1 to $2. But notice whoever made this graph, and this is a really common mistake, they didn't just double, the proper thing to do would have been to do this, just double one of the dimensions, right? So now, Now you have conveyed what you want. We've doubled the area of the box. But whoever made this graph, they doubled both dimensions. So now we got a box, how many times bigger, how many of this little square fits in the bigger square? Yeah, this one's really 4 times bigger, because we doubled both dimensions. And so again, it's a misuse. The one that I had that got torn up was somebody showing, they were trying to show how much bigger NASA's budget, the United States NASA's budget is than every other space entity in any other country around the world. And it is a lot bigger, but somebody did the same thing. They changed both dimensions. So instead of getting an accurate reflection, it looked even more enormous than it actually already was. So that became a problem. So the last bad graph I've got here is this one. We've got a pie graph, and pie graphs tend to be labeled with percents in them. And each piece of pie is supposed to, or when you draw it, each piece of pie is supposed to represent that percent. When you have a circle like this, what should all the percents add up to? Yeah, 100%, a whole. Okay, so all the percents and this, again, becomes a problem. Sometimes you get pie charts that the percents actually only add up to 95% because somebody hasn't included all the categories, or you get like 102%. So the percents should always add up to 100, not more, not less, when you have a pie chart, if it has been done properly. There's lots of there's lots of other things. I never think when because I'm not that smart of a person when I'm online to copy and paste some of the ones to put on pages here. But here's what I've got for you. Okay, because I know everybody wants some bonus points, and I am a kind and compassionate man. So here's what you're going to have leading into test 6. When you're online, I want you to look for and submit some examples from your reading, whether it's online or books or magazines or news sites or wherever, of misuses of statistics, whether maybe you notice something was done as a convenience sample, or whether you see a graph that has just been done poorly. And so what you can submit to me, you can submit links, you can submit printouts, whatever, and you get 2 points for each, up to 10 points. So you can do up to 5 misuses of statistics. And you can give them to me on the day that we take our last test. I won't take them after, because these points are going to be part of your last test on the 6th one. Okay, so